Hello students, our first topic in derivative differentiation is derivative of composite functions. In this topic, we will prove the first theorem for composite functions. Statement for the theorem is if y equal to f of u is differential function of u and u equal to g of x is differential function of x such that composite function y equal to f of g of x is differential function of x, then dy by dx equal to dy by du into du by dx. Now in this theorem there are three variables. We can divide these variables in two groups, that is independent variables and dependent variables. Here y is dependent on u and u is dependent on x. Therefore here x is independent variable and other u and y are dependent variable. Now for this, here we have to consider first of all increments in these three variables. First we have to consider increments in y and u as delta y comma delta u. B, the increments in y comma u respectively. Corresponding to increment delta x in x. X is independent variable, therefore take last as corresponding to increment delta x in x. Now as independent variables increment delta x tends to 0, then delta y tends to 0, comma delta u tends to 0. Now firstly we have to consider now delta y by delta x equal to delta y by delta u into delta u by delta x. We can consider this formula in terms of increments. Also we can take it as value by cancelling delta u, we get delta y by delta s. Here are the increments, that means we can take in terms of this value. Now we have to convert this delta in differentiation, that is d. To convert this delta into d, we have to consider Leibniz notation. So to converting this by the Leibniz notation, first we have to take limits, taking limits on both sides as independent variable is delta x, as delta x tends to 0. Therefore limit of delta y by delta x as delta x tends to 0 is equal to limit of delta y by delta u by delta x as delta x tends to 0. You can separate limit for both the terms as limit of delta y by delta u into limit of delta u by delta x. Restriction for limits is delta x tends to 0, delta x tends to 0. Now here denominator is delta u and increment restriction is delta x tends to 0. We have to change this restriction. Delta x tends to 0, then our delta u also tends to 0. Therefore we can write delta u in terms of delta x. Therefore we are changing this term in next step, limit of delta y by delta x as delta x tends to 0 equal to limit of delta y by delta u as delta u tends to 0, and second term as it is limit of delta u by delta x as delta x tends to 0. Reason for this change is as delta x tends to 0, comma delta u tends to 0. Now here y is differential function of u and u is differential function of x. We have to write here where y is differentiable function of u, comma u is differentiable function of x. Therefore, by using Leibniz notation, dy by du equal to limit of delta y by delta u, as delta u tends to 0, and next derivative is du by dx is equal to limit of delta u by delta x, as delta x tends to 0. We can write this equation as equation 1. Then by using this equation 1, we can change the right side of this equation. Therefore, our above equation becomes limit of delta y by delta x, as delta x tends to 0, is equal to dy by du into du by dx. The right side of this equation exists. Right side of this equation exists. Therefore, left side also exists. Therefore, left side is converted into required results. For this purpose, we have to write here as here RHS exists. Therefore, LHS also exists, and it is equal to dy by dx. Therefore, our final result becomes dy by dx equal to dy by du into du by dx. These are final results for derivative of composite function.